Good afternoon, everyone, and thank you for coming to listen to my talk. Today I will be talking about a TrueAllele Casework validation study on PowerPlex 21 mixture data. TrueAllele Casework is a computer system developed by Cybergenetics that is used to interpret DNA mixtures. The system uses hierarchical Bayesian probability modeling and Markov chain Monte Carlo statistical sampling in order to solve for the genotypes in a DNA mixture problem. The system is designed to have a very interactive as well as efficient analyst workflow. As you can see on the left, we have our user client view station where an analyst can input their STR data, ask mixture questions about the data, and upload these questions to the database server, as you can see in the middle. This database server is a tower processor that can have anywhere from 10 to 12 processors all running in parallel to solve mixture problems. The benefit of having this parallel processing is that an analyst can upload multiple mixture questions at one time, and the computer can simultaneously solve them, therefore reducing the analyst's time of actually sitting at the computer and doing the interpretation. There is also capability for interpret and match expansion by adding additional processors, as you can see on the right. These processors can solve their own mixture questions independently or work on the matching database problems and then write their answers back to that database server, which has a central server in it where all of these answers are stored. After all the processing is done, an analyst can then download the answers from the TrueAllele system back onto their view station and review these answers in very visual forms using using the viewer software, which is a visual user interface. TrueAllele has been extensively validated with over 25 validation studies done by either Cybergenetics or other groups. These validations have been done on either laboratory synthesized data as well as on casework samples. What we're seeing here are the 7 peer-reviewed published validation studies. The 4 on the top in the lighter blue were done on mixtures of known composition. This allowed us to test the capabilities and limits of the TrueAllele system since we knew the compositions of all of the mixture contributors. And the 3 papers on the bottom were done on casework samples, which allowed us to see how TrueAllele behaves in practice on actual, less pristine casework data. The 2 most recent publications will come out in the Journal of Forensic Sciences next year. So as you all know, DNA mixtures are a common form of biological evidence found at crime scenes. The STR data derived from mixtures typically contains more than 2 alleles per locus. What we're seeing here is 1 locus from a PowerPlex 21 3-person mixture, and with our base pair size on the x-axis, and on the y-axis the peak height measured in relative fluorescent units. Each peak has a size and a height, and with the peak heights corresponding roughly to the amount of the genotype contributions. And you can see there's an overall pattern to the data at this 1 locus. So what TrueAllele does is it works to separate out the component genotypes to a mixture. And what we're seeing here is the inferred mixture weights for that 3-person mixture that we saw above. You can see that TrueAllele was able to separate out this mixture into its major, middle, and a minor component. What we're seeing on our x-axis is the mixture weight binned by decile ranging from 0 to 100%. And on the y-axis, we see the number of times that the system visited that specific mixture weight. And as you can see, TrueAllele was able to nicely separate out this mixture into its 3 components. So how TrueAllele works is it works to virtually try out every possible genotype combination for each contributor at every locus to a mixture. And it does this by statistical simulation. And what the system's trying to do is it's trying to explain the peak pattern of the STR data at every locus. So what we're seeing here is 1 proposed explanation for this 1 locus for the 3 contributors to this mixture. In orange, we're seeing for that major contributor, the computer is proposing an 18-19 allele pair. And then in blue, it's proposing another person being a 15-23. And in green, you can see that there's that 3rd minor component that the computer is proposing to be a 21-21. And as you can see, these colored boxes roughly fit the overall pattern of the data, and therefore this is a good explanation of the data, which receives a higher likelihood. Now, this isn't the only explanation that the system tries out. It basically considers tens of thousands of other possibilities as well, assigning them each some likelihood. For example, the system may move the box from the 18 peak over to 16, but there is no 16 peak there, so therefore that's a worse explanation of the data and receives a lower likelihood. The system is also objective in that it doesn't know the reference genotype that you're going to be comparing to later on. So in this study, we looked at 62 different mixture items ranging anywhere from 2 to 3 to 4 contributors, with most of the mixtures being from 2 and 3 contributors. This yielded a total of 168 genotypes that we looked at in this study. And what we did is we examined TrueAllele's sensitivity, specificity, and reproducibility, and we measured that in log-LR values. Where here, we're saying that the log-LR is just the number of zeros in the match statistic. So, for example, a log-LR of 6 is a 1 followed by 6 zeros, or a million. The mixtures in this study were amplified using the PowerPlex 21 STR kit. PowerPlex 21 is developed by the Promega Corporation and is said to have more discriminating power than the 16 locus kits. We looked at mixtures of known composition for 2, 3, and 4 contributor mixtures. These mixtures were developed by the New South Wales Forensic and Analytical Science Service and were size separated on a 3500 XL genetic analyzer. After we received the STR data, a trained TrueAllele operator took the STR data files and input them into the TrueAllele Analyze module, where the peaks were quality checked and then quantitated. Then the operator uploaded the data to the database server and then asked the forensic questions of the data. They asked the computer to solve for either 2, 3, or 4 unknown contributors, depending on the study design. Each request was set up using 100,000 burn-in, 100,000 readout, and CMC cycles, and every request was set up at least in duplicate to measure the reproducibility. After these questions were uploaded, the computer solved for the evidence genotypes, inferring 1 for each contributor and writing down the probability distribution for each inferred contributor. After that was done, the TrueAllele operator went back, downloaded these evidence genotypes, compared them with the known reference genotypes relative to the population genotypes in order to calculate the likelihood ratio match statistics, which were then recorded as logarithms. So in this study, we defined sensitivity as the extent to which an interpretation method correctly includes a true contributor. And what we did is we took the 168 genotype match statistics from those 62 mixture items and plotted those match statistics in a frequency distribution. And what we produced were the log-LR match distributions for each contributor group. So what we're seeing here is in blue on the top, the frequency distribution for 2 contributors. In red in the middle, we see for 3 contributors. And for 4 contributors, we can see the sensitivity histogram for 4 contributors in green. And we can see on our x-axis, we have our log-LR information ranging from a -8 all the way up to 29. And we see for each mixture group that the range of information spans a wide range. So for 2 contributors, you see it goes all the way from low information around 4 all the way up to almost full single source information, or a log-LR of 29. And we see that for all 3 mixture groups as well. We calculated then the average match information for each mixture group. So for 2 contributors, we see that we have the average match information was about 20 zeros. For 3 contributors, it's about 14 zeros. And for 4 contributors, it's about 5 zeros, or in the 100,000s. And we're also seeing that shift in the left, closer to 0, of the information as you go from 2 to 4 contributors. And this is expected due to the increase in complexity and the increased uncertainty when you have more contributors to a mixture. Overall, though, we're seeing a high sensitivity with positive match scores obtained for the majority of the genotype matches in the study. We then looked at the false exclusions by examining false negative tail distribution. And so what we're seeing here are just the counts for each log-LR bin, where the log-LR of -1 represents any false exclusion observed between a log-LR of 0 and a log-LR of -1. And we can see for 2 contributors, TrueAllele found all 56 genotype matches. For 3 contributors, it found over 90% of the genotype matches. And for 4 contributors, it found about 75% of the genotype So we see that TrueAllele has high sensitivity with few false exclusions, more false exclusions seen when you have increased uncertainty in the data. We also examined TrueAllele specificity, and here we define specificity as the extent to which an interpretation method correctly excludes a non-contributor. So to look at this, we took those 168 genotypes, compared them to the 10,000 random non-contributor reference genotypes from the two ethnic populations used in the study, which were the Australia National Caucasian and the Australia National Asian databases. And since TrueAllele is able to quantify these exclusions, we were able to plot the frequencies of those negative match statistics, producing log-LR mismatch distributions for each contributor group. And what we would expect are highly negative distributions, far to the left of 0, since these are true non-contributors. And that's what we see here. So for each contributor group, now we're seeing 0 all the way to the right, or no information, to a negative 40 all the way on the left. And what we see are these highly negative mismatch distributions for each contributor group, with averages ranging from negative 30, which is 1 over a 1 followed by 30 zeros, to negative 21 with 3 contributors, to a log-LR of negative 16 with 4 contributors. And again, you can see that shift closer to 0 as you go from 2 to 4 contributors, which is expected as there is more uncertainty with 4-person mixtures. We can also see that there are very few false positives to the right of 0. And we were able to quantify those false positives. So looking at the false inclusions, we examined the false positive tail distribution. Now we're seeing all of the counts for log-LR values in the middle and for each bin. And so what we're seeing for a log-LR of 0 for here is defined as anything with a log-LR between 0 and 1. And what we can see is that in close to the 1 million comparisons per mixture group, that most of those false positives were seen between a log-LR of 0 and a log-LR of 2. For any log-LR greater 3 or greater, the false positive rate was about 1 in 80,000, or less than 1,000%. So therefore, we can say that TrueAllele has high specificity as well, with few false inclusions. We also measured TrueAllele's reproducibility, and reproducibility is defined as how precisely the computer is able to get the same answer on looking at the same mixture data. And so what we did is we ran each request, at least in duplicate, and we plotted the log-LR from the first computer run on the x-axis and the log-LR from the second computer run on the y-axis. And what we would expect is if TrueAllele gave the exact same answer every time, that all of these data points would line up on an equal information line. But since statistical sampling is used to solve TrueAllele's probability equations, there is some spread around this line as expected. And we were able to measure that spread by measuring the within-group standard deviation. And what we see for 2 contributors on the top is we have a within-group standard deviation of around 0.3, which roughly corresponds to a factor of 2 difference between the 2 independent runs on the same data on average across that mixture set. And for 3 and 4 contributors, the reproducibility value was a little bit higher, around 0.7. Overall, though, all of these within-group standard deviations are less than a log-LR of 1 band. Therefore, TrueAllele shows high reproducibility, which you can see by the nice scatter plots as well. So from the study, we were able to conclude that TrueAllele Casework mixture interpretation on PowerPlex 21 mixture data comprising of 2, 3, and 4 contributors is objective in that it never sees the reference genotype while it's doing the inference process. It's sensitive in that we see positive match statistics with few false exclusions spreading a range of match statistic values. It's specific in that we see those highly negative mismatch distributions with few false inclusions seen. And it's also reproducible in that we're getting nearly the same answer every time on when we ask the computer to solve the same mixture question more than once. TrueAllele has been used in a variety of criminal cases, ranging various offenses. Often we'll get cases where other methods can't produce a statistic, so really complex cases, low level, or mixtures of family members. We've received a variety of cases recently, including mixtures of family members that encompass offenses of child rape, homicides, 3 or more person mixtures, and TrueAllele was able to separate out these mixtures of family members into their component genotypes. TrueAllele has also been used on a high-profile multiple homicide case here in Australia to separate out a 5-person mixture of family members because no other technology in the world could do that. There have been over 200 TrueAllele reports issued in many US states as well as other countries around the world. These reports have been issued by both cybergenetics analysts as well as analysts in crime laboratories. TrueAllele is currently online in 3 laboratories in 2 US states as well as in the Middle East. So where is TrueAllele today? TrueAllele was invented over 20 years ago by inventing the math and algorithms, and computer systems followed shortly thereafter. We currently support 10 laboratories, their users in their workflow. 3 of those labs are online using TrueAllele in their everyday workflows, and the rest of the groups are working to come online as well. The system has been validated extensively, as I said. There are now over 25 validation studies done. We're also working to educate the community by just presenting at conferences and offering workshops so people can learn more about the TrueAllele system. We also offer training and certifications for analysts with currently over 200 students trained. We're also working to help people learn how to be more comfortable testifying about TrueAllele results in court as well. TrueAllele has been through 5 admissibility hearings, and about 20 trials have gone to court where analysts have testified about TrueAllele. A lot of our cases will get plea bargains out of because the lawyers see the match statistics and then they just take the plea bargain. And we're also working to make the ideas understandable with over 200 reports issued. We also offer education to lay people such as juries, judges, and lawyers of how to interpret and look at and make sense of these likelihood ratio match statistics. So to learn more about TrueAllele, you can visit our website, www.cybergen.com/information. We offer a variety of courses. There's newsletters, a newsroom, and many presentations and publications. Many of our publications are present on our YouTube site as well. And so if you have any questions, feel free to email me at Jennifer@cybergen.com. That's it. Thank you very much for your time.